Hi, this is Module 2, Lesson 8, Getting Down to Business. These are the notes. Let's read this first one here. Calcurama had a net income of $5 million in 2010, while a small competing company, Computafest, had a net income of $2 million. The management of Calcurama develops a business plan for future growth that projects an increase in a net income of 0.5 million per year. So this is Calcurama, who started with $5 million. And then the management of Compufest develops a plan aimed at increasing its net income by 15% each year when they started with $2 million. So letter A, create standard mathematical models, so table, graph, equations, for the projected net income over time for both companies. 10 to precision. Make sure we're being accurate on these and labeled. So here we're getting down to pickiness of making sure we can do our graphs and tables correctly. So let's start with Calcurama, and you're in blue. So let's do our table. So Calcurama had 0, 5, so in the 0 year, 2010. I'll put year on here, years, and that's after 2010. And this was their money amount in millions. So at 0, 2010, they had $5 million. If they gained $500,000 every year, this would be 5.5. The second year would be 6 million, and the third year would be 6.5 million. So if we go to make our equation for that, f of x is our starting amount is 5 million, and we're adding 0.5 each year. So we're adding repeated addition. So that's 0.5. Oh, and we don't actually need the parentheses because we started with the 0. When I put a 0 in here, I will get a 5 for my answer. So let's go ahead and go to our Jamboard and do this one out. So this is, let's get a pen going here. Calcurama. So they're going to have, let's be a little more accurate. They have the table of 0, 5, 1, 5.5, 2, 6, and 3, 6.5. So I'm going to make my table on the lines here. Right here. They're all positives, so I don't need to worry about the negative ones. So I'm going to start with 0 here. Here I'm going to have my x values, so my years after 2010. And this one I'm going to have my dollars in millions. So right now, I think what I'm going to do is I'm going to count by ones over here. So I'm going to go 1, 2, 3, 4, 5 and give myself some space. And over here, I'm going to count by ones. So 1, 2, 3, 4, 5. I'll put 5 right here, 6, 7, 8, 9, 10. Okay. Actually, you know what? I've changed my mind on that. Let's skip on this. Here's going to be 1, 2, 3, 4, 5, 6. So 7 will be right up, 6.5. So my first year is a 0. 1, 2, 3, 4. Here's my 5. So I'm going to do this one in blue, since this is my Calcurama. We did blue in the other one. So 0, 5, and then 1 was 5.5, so I can go in between here. 6 is right here, and 3 was 6.5, so that's right in here. And actually I can connect them because it's they're hoping to grow it each year, so in theory it's going to keep following that pattern. All right, let's go look at ComputeFest. So theirs over here, same idea, years and money, and they had a 0, started with 2 million, but they went up 15%. So keep in mind I have to go up 115% because I want that 2 million involved. So that would be 2.65. 2 would, oh, sorry, take that back. Looked at my wrong numbers. So that actually, 1 is 2.3, 2 is 2.65, and then I'm going to bring this down a little bit so I can get a 3 is 3.04, and 4 is 3.5. Okay, so when I do my equation, I know that I start with 2 million, and I'm going to repeat a times 1.15, 115%, and because it's a repeated multiplication, there's a exponent there. And I don't need the n minus 1 because I've started with the 0. So let's go to the Jamboard, and I'm actually going to put this one on the same graph. So let's go ahead and change back to the black here, and so this is ComputeFest, and their table was 0 and 2, 1, 2.3, 2, 2.65, 3 was 3.04, and 4 was 3.5. Okay, so I'm going to draw this on the same graph in red. So 0 is 2 this time. This one over here in red. 1 is 2.3, so it's not quite the 2.5 mark. 2 is 2.65, so that's a little bit above. Oh, wait, no, it's not quite to the 3. 2.65, trouble's writing here. 3 is 3.04, so it goes up with the 3. And 4 is 3.5. Wait a minute, 1, 2, 3, 4. Oh, shoot, I counted those wrong. Well, I guess we started with a 1 down there. 4 is 3.5, so we'll put it right here. So it's hard to tell on this one, but there is a little bit of a curve going on here. Not straight, because you can tell I'm not doing the same distance in between all of them, but there's a slight curve as we're going through here. So let's go back to here. All right, compare the two companies. How are the representations for the net income of the two companies similar? How do they differ? What relationships are highlighted in each representation? So we're going to put these color code them. So Kalkurama, I'll put in blue. So this one is linear, right? It was the straight line. It had a slope of 0.5, because that was our 0.5. I didn't put my decimal very well in there. And it starts with 5 million. So that's kind of the details on that. The ComputeFest is exponential. You notice there was the exponent in there. It is the common ratio is 1.15. So its ratio is bigger than the slope. And we know exponential is going to go faster than the slope, than a regular slope would. And this one starts with 2 million. And what they have in common, let's do that in black. Both are increasing and continuous. They all make money and they're all doing that with a line. So if both companies were able to meet their net income goals, which company would you choose to invest in? Well, I personally know that exponential is better, will increase faster in the long run. So I'm going to put ComputerFest. I'm not actually going to write everything out, but because it's exponential, we know that in the long run, it will eventually get past that 5 million and be going faster than a 0.5 million each year. So there's the first part. D. When, if ever, would your projections suggest the two companies have the same net income? How did you find this? So, and then will they ever have it again? So if we were to keep graphing these, and you can actually do this on Desmos. Let's just go ahead and do that. And let's go ahead and put these on the graphing calculator. So I'm going to put in my first one and do a y equals 5 plus 0.5x. And let's add another one and do a y equals 2 times 1.152 the x power. So if you notice on here, we had our ComputerFest is the linear one. Sorry, Calcurama is the linear one. ComputerFest is the blue one. And if we keep going out here, we see that they will eventually cross right here. Well, we can't really see with our graph where that is. So let's see, 10, 11, 12, 13. So it's between years 12 and 13. And if we get right on that point, it's year 12.29. So about a third of the way into the year of the 12th year, so 2022, it's 12 years after 2010, it will be in there. So we're going to go back to our thing. When, if ever, would you predict them to have the same net income? So it's between 12 and 13 years after 2010. So approximately 2022. How do we find this? Well, we use the Desmos graphing calculator. You could have guessed and checked as well. Will they ever have the same net income again? Well, let's look. If we take this and zoom out, are they ever going to cross any other times? Now they crossed back here, but we can't go backwards. We're only looking forwards. So because the exponential is increasing crazy now, they will never cross again. So will they cross again? No. Since we are creating models for these companies, we can choose to have a discrete model or continuous model. What are the advantages or disadvantages of each type? Well, I'm just going to talk through this one, so I'm not writing all of it out, but the continuous is good because it shows all those points between years and it shows kind of when that growth really increases, especially with the ComputerFest. And that can be helpful if you're really analyzing kind of in between different stuff. Discrete, though, helps simplify things. So if you're just needing a year in total or just needing to present something to maybe your company, you want to kind of keep it simple. And that would be a better way of doing it is if you have the discrete. Thank you for joining us and hope that helps.